Hi students, welcome back to our new session. I hope you all enjoyed with my explanation in the previous videos. Today I would like to discuss about chemical properties of hydrocarbons which comes under carbonates compounds of your 10th class syllabus. This is due to the request of one of the students who requested me in comments that sir please explain carbon compounds topics. So hence because of that I opted to explain about primarily chemical properties of hydrocarbons. I hope you all will enjoy this. Please after completion of my class subscribe my channel, comment on it, like it, and if any doubts are there you can post in the respective comment section. Okay, let's start for this today's class about chemical properties of hydrocarbons. So what are hydrocarbons? I hope you all have a basic idea. What are hydrocarbons? Hydrogen and carbon containing compounds are called hydrocarbons. Hydrogen and carbon containing compounds are called hydrocarbons. Or simply, what is the meaning of carbon compounds? Carbon containing compounds are called carbon compounds. Hydrogen and carbon containing compounds are called hydrocarbons. For example, CH4, which is nothing but methane. It is a hydrocarbon because it contains hydrogen as well as a carbon. In this formula, we have 4 hydrogens and 1 carbon. It is a hydrocarbon. So, we are going to discuss about different chemical properties related to these hydrocarbons. In those, the first property which comes under this is first one is combustion. So, what is the meaning of a combustion? The process of burning of a substance in the presence of air or oxygen is called as a combustion. The process of burning of a substance in the presence of oxygen or air is called combustion. I hope you understood. For example, so carbon, if burnt in presence of oxygen, gives rise to carbon dioxide. When you burn carbon, it not only produces carbon dioxide gas, even certain amount of heat energy and even light energy. Heat and light is also produced. So if you burn carbon in presence of oxygen, gives rise to carbon dioxide and as well as a heat energy and light energy. So this is simply called as a combustion of carbon. If you combust any hydrocarbon compound, nothing but hydrogen and carbon containing compounds. For example, take the example of methane. If you burn methane in presence of oxygen, gives rise to what? Carbon dioxide. Not only carbon dioxide, along with the carbon dioxide, you can able to get water plus heat and light. Heat energy and light energy is also obtained. Now here in these two reactions, what commonly you observe is heat and light. Now heat is liberated, heat energy is liberated, heat energy is evolved. Hence the combustion reactions can be called as exothermic. These are exothermic reactions. We can add examples of exothermic reactions. Okay, like methane reacts with oxygen, gives rise to carbon dioxide and water. This is an exothermic reaction because heat energy is liberated. Are you understanding? So, combustion means the process of burning of a substance in the presence of oxygen or air, nothing but is called combustion. Okay, for example, C plus O2, it is a carbon. It is a carbon. When you burn carbon in presence of oxygen, gives rise to carbon dioxide, heat and light. It is an exothermic reaction. Now take the example of methane, which is a hydrocarbon. If you burn methane in presence of oxygen, gives rise to carbon dioxide. Not only carbon dioxide gas, even water is also obtained because we have hydrogen here. So now I would like to balance this. One carbon is there, one carbon balanced. How many hydrogens are there? 4 hydrogens are there. Here you got how many? Only 2. Then I have to keep 2H2. Okay, that is CH4 plus O2 gives rise to CO2 plus 2H2. Hydrogens are balanced. We need to think about oxygens. Total how many oxygens are there? Here 2 plus here 2 are there, 4. Then I will keep 2O2. That is CH4 plus 2O2 gives rise to CO2 plus 2H2O. heat and light energy is obtained. Is it clear? So this is one example for combustion reaction. Now one more, if I write a few more examples. Sir, is all the combustion reactions are exothermic? Definitely, all the combustion reactions are exothermic reactions. I will go with some other example. Now I can go with a compound like C2H6, which is called ethane. It is also a hydrocarbon. It is a saturated hydrocarbon. It is a saturated hydrocarbon. That is because carbon to carbon we have single bond. Even the first case also around the carbon all are single bonds. Methane is also saturated hydrocarbon, and here is ethane is a saturated hydrocarbon, that is which comes under alkanes. So reacts with oxygen, undergoes combustion in presence of oxygen, gives rise to carbon dioxide, water, and heat and light energy. Remember this. So we'll balance this. If you want structurally, even I will draw the structure of this and I can explain. Okay, C2 plus H6 plus O2 gives rise to CO2 plus H2. We need to think about balancing. How many carbons are there? 2 carbons are there. Now if I balance carbons 2 by keeping here, carbons are balanced. We need to think about hydrogens. Total how many hydrogens are there? 6 are there according to the formula. Now here you got how many? Only 2. Then I have to balance hydrogens. I will write as 3. Is it clear? Now, how many hydrogens are there? 6 are there, is balanced. When you think about oxygens, 2 2 ja 4 plus 3. How many are there? 7. Then I have to balance this oxygens. Then I can write this one as 7 by 2. Is it clear? It will become 3.5 into 2. That is what? 7 oxygens. 2 2 ja 4 plus 3, 7 oxygens. Oxygens are totally balanced. No, 7 by 2 O2, because we can't write directly as 7O, because oxygen occurs in elemental form. Remember this. Oxygen occurs in elemental form, that is a molecular form, that is in the form of O2, not in the form of O, nascent oxygen. Okay, we can't react like that. Are you understanding? Okay, so it is also an exothermic reaction, because during combustion, heat energy is liberated. Okay, we can denote symbolically as plus Q, because exothermic reaction, heat is evolved, we can write as a plus Q. Are you understanding? Next one, if I take the example, now I will, after explanation of this particular basic concept, I will go the comparison of combustion of saturated, unsaturated hydrocarbons. Now I will go with one more example related to unsaturated hydrocarbon, C2H4, which is called as ethene. I will write as C double bond C, hydrogen, 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 hydrogen. In whatever the way you would like to, you can write. Now, or C double bond C, here hydrogen, hydrogen, hydrogen. Now, carbon to carbon double bond is there, and 2 carbons are there. It is what? Ethene. Okay, now it undergoes combustion reaction, presence of oxygen, give rise to common products. You know that CO2 and H2O. And even we know that exothermic reaction, heat and light, that is, I will write as heat and light. Okay, so C double bond C. No, this is unsaturated compound. Now I need to think about balancing. 2 carbons are there. So 2 carbons are there, then I need to think about balancing. I will write a short form of equation here. C2H4 plus O2 gives rise to CO2 plus H2O. Now total how many carbons are there? If I won't add anything in front of it, if I go the simply C2, 2 carbons, then I can write here as a 2C. 2C, carbons are balanced. We need to think about hydrogens. How many hydrogens are there? 4 are there. Then I will keep a 2 here. So hydrogens are also balanced. I hope you all are understanding this. Okay, next we need to think about oxygens. In products, how many you got oxygens? 2 2 ja 4 plus 2. How many? 6 are there. Then I will keep a 3 here. That is C2H4 plus 3O2 gives rise to 2CO2 plus 2H2O. That is nothing but here is heat and light. Why I showed this one with a plus Q? Reason is it is an exothermic reaction. Okay. Now we should have some basic idea. What is the meaning of complete combustion and incomplete combustion? Okay, combustion is of 2 different phases. One is called as a complete combustion, next is incomplete combustion. Okay, during complete combustion, the flame so obtained, appears blue in color. Complete combustion is generally observed. Complete combustion. Complete combustion generally observed in case of saturated hydrocarbons. carbons. That is CH4 for example. Okay, or some other. You can go to some other, no problem. CH4 burns in presence of oxygen gives rise to CO2 plus H2O I told. Only one carbon is there balanced. How many hydrogens are there? 4 that they need to balance about okay, that is hydrogens are balanced. Now oxygens are how many? 2 plus 2, how many? 4. Then we will write 2O2 and this is a plus Q. So it undergoes complete combustion. Methane undergoes complete combustion. Okay, so when the respective hydrocarbon undergoes complete combustion process, okay, gives rise to formation of a which color flame means blue color flame. Complete combustion means the color of the flame will be blue. Remember this. The flame obtained, flame color is blue. Remember this. Okay. Now in case of it does not form even, it does not form any residue. Residue in the sense soot like or any carbon deposition will not take place. Okay. Soot will not be formed. No smoke. Complete combustion. No smoke. Now if I talk about incomplete combustion. Incomplete combustion. In incomplete combustion, there is a chance of appearance of soot, more smoke. Okay, that is a more carbon decomposition, more carbon deposition. These all are observed. For example, next one is incomplete combustion. Incomplete combustion generally observed in case of unsaturated hydrocarbons which are having a carbon to carbon double bond or a triple bond. Incomplete combustion. For example, if I go with a camphor, you heard about this camphor. We used to perform puja. During puja, we used to lit it in front of God. Now, when you observe the burning flame of the camphor, what do you observe? You will observe more smoke in that. I hope you all understood this. You observed many number of times. So, in that, more soot is there, more smoke is there, more carbon deposition taking place. If you keep your hand at the top, you may observe that carbon deposition soot will be formed. Reason is incomplete combustion. And if you observe the flame, it appears yellowish, okay, or orangish. Okay, yellowish or orangish flame is observed. That is because of incomplete combustion. Are you understanding? Incomplete combustion generally observed in case of camphor, which comes under unsaturated hydrocarbon compound. Next one is naphthalene. Naphthalene. Few more examples are there. Okay, these all comes under incomplete combustion. In incomplete combustion, the flame, okay, the flame appears yellow or orange or maybe, okay, maybe a color variation can be observed, okay, not of blue color. Remember this, okay. So in incomplete combustion is observed the amount of energy emitted is less in incomplete combustion. Okay, in complete combustion, the amount of energy emitted will be more. Heat energy emitted will be more. Amount of heat energy liberated will be more. I am not talking about light. Okay, so in case of complete combustion, we will observe, okay, non-luminous flame in complete combustion. Okay, we will observe non-luminous flame. In incomplete combustion, we will observe luminous flame. Luminous flame. Non-luminous, luminous. Incomplete combustion, luminous. Okay, complete combustion, non-luminous. If you observe candle, okay, candle. Now, please thoroughly observe that. Okay, you will find two different colors, two different zones. Okay, you will observe the yellowish zone and you may observe the blue color zone. So, blue color zone gives rise to what flame? That is a non-luminous flame. Okay, now next one is yellow, that is a luminous. I hope you all understood this. Okay, so now if you want, sir, can you please explain with some other example related to this combustion? Means I will go with the alcohol. So ethanol. I will go with an example of alcohol, that is CH3CH2OH is a chemical formula of ethanol, which is an alcohol, or we can write as a C2H5OH. This also undergoes a combustion reaction in presence of oxygen, gives rise to carbon dioxide, water and heat energy. Nothing but plus Q means exothermic reaction, I told already, that is both heat and light. Okay, now I will balance this. C2H5OH plus O2 gives rise to CO2 plus H2O. Now, if I go with only 2 carbons, okay, that is 2CO2, 2 carbons are there here, 2 carbons balanced. How many hydrogens are there total? 5 plus 1, 6 are there. Then I will keep 3. Hydrogens are balanced. We need to think about oxygens. How many oxygens are there? 2, 2 ja 4, 3, 1 ja 3. That is 7 oxygens are there. Then I will make it as a okay, total how many oxygens are there? Total 7 are there. 2 2 ja 4 plus 3, 7 are there. Then here already 1 is there. Then I can keep here as a 3. That is 1 plus 6, 7 balanced. Everything is balanced. So this also comes under combustion reactions. The next type of chemical properties related to hydrocarbons is oxidation. You know, I hope you all know what is the meaning of oxidation. The process of addition of oxygen or removal of hydrogens or even removal of electrons is called oxidation. But in this particular mechanism, reaction mechanisms, will be observing removal of oxygen or addition of oxygen, okay, or removal of hydrogens is observed. Addition of oxygen primarily and removal of hydrogens is observed. What is the meaning of oxidation? The process of addition of oxygen or removal of hydrogens is called as a oxidation. Okay, I hope you understood. Addition of oxygen, for information's sake, addition of oxygen or removal of hydrogens, hydrogen atoms, addition of oxygen atoms, nothing but oxidation. So all type of hydrocarbons undergoes oxidation reactions. Okay, but primarily according to our 10th class syllabus related to both CBSE and SSC students, we are having oxidation reactions of what means ethanol. Okay, so sir, oxidation definition is okay. So if a chemical substance is undergoing oxidation, what it is called as, in with what name it is called, means the chemical substance which undergoes oxidation is called as an oxidant, and the chemical substance which oxidizes another chemical compound is called as a oxidizing agent. For example, if somebody is giving oxygen to me, then I will become oxidant and that person will become a oxidizing agent. He oxidized me by giving his oxygen, or he oxidized me by taking out hydrogen from me. So that is the best example. Addition of oxygen or removal of hydrogens. If anybody is giving oxygen to me, then I will become oxidant. That person will become oxidizing agent. If anybody is removing hydrogens from me, then I will become a oxidant. He will become a oxidizing agent. I hope you understood. Okay, come on, next one. And he can also become a reductant, because oxidizing agent may be act like a reductant. Okay, next we'll be talking about oxidation reactions in terms of ethanol. I will demonstrate with a simple activity before. Okay, then I will write the chemical equation. Now let us take a test tube. In this, pour few ml of ethanol, C2H5OH, nothing but ethanol. Even you will find the formula in the books even like this also, CH3CH2OH. I am going to take 3 ml of ethanol. Okay, to this 3 ml of ethanol, okay, I am going to add acidified potassium dichromate, that is acidified potassium dichromate I am going to add. So what is the process, sir? Explain clearly, sir. Then listen carefully. Let us take a glass beaker, pour few ml of water in the glass beaker. Keep the glass beaker on a tripod and start heating the glass beaker by using a Bunsen burner. By using a Bunsen burner, I am going to heat it. Before I heat, please keep the test tube, okay, containing the ethanol, C2H5OH, okay, in the beaker containing the water. Slowly start heating the test tube containing ethanol by using a water bath or on water bath. While you are heating, slowly add smaller and smaller quantities of acidified potassium dichromate K2Cr2O7 acidified potassium dichromate. Acidified potassium dichromate is having a orange color. Is having a orange color. Okay, when you add acidified potassium dichromate, which is in orange color, drop by drop, okay, slowly the color of the acidified potassium permanganate, okay, acidified potassium dichromate, sorry, acidified potassium dichromate changes into what color, in the sense that is a green color. The appearance of the green color, with the appearance of the green color in the respective solution, okay, will confirm that oxidation reaction is taking place. Oxidation of ethanol is taking place. We have to understand. Now, what to do? Okay, with this reaction, okay, what is the reaction mechanism and how to write this? Now, I'm taking ethanol C2H5OH, that is ethanol. Now, the reaction mechanism I'm writing ethanol. I am going to add acidified K2Cr2O7. Okay, I am going to heat it on water bath. Heating process should be there. If you won't heat it, there is no chance of oxidation reaction. Okay, now after adding acidified potassium dichromate, that is to ethanol, it is going to convert initially into ethanaldehyde or acetaldehyde, that is CH3CHO. Okay, CH3CHO is the formula for, okay, ethanal or acetaldehyde. Understood? Again, this is going to convert, even the continuous, this acidified potassium dichromate, okay, acidified potassium dichromate Cr2O7, it is going to convert it into acetic acid CH3COOH. This is the final product which is obtained after complete oxidation of the ethanol. So ethanol initially converted into ethanal acetaldehyde. Okay, next is going to be converted into finally acetic acid. This is what acetic acid is also called as ethanoic acid. Is also called as a ethanoic acid. Remember this. It is also called ethanoic acid. This is a complete oxidation reactions, okay, of ethanol by using acidified potassium dichromate. I hope you all understood this. Okay, in these reactions, heat energy supply is a must. We have to heat it. Okay, then the reaction process and finally the product acetic acid is obtained after complete oxidation of ethanol. Okay, I hope you all understood this. Okay, now one more way to do this process. Okay, that is by using one more way to do this process is maybe the reaction, okay, with alkaline KMNO4. Reaction with alkaline KMNO4. Please concentrate. Alkaline KMNO4. Now we are having a CH3CH2OH, which is nothing but C2. I will write it as C2H5OH. Okay, anyone, both are same only, na? But I am writing clear formula like this and like this. In some books it may be like this, in some books it may be like this directly. No, that is in presence of, we are having is alkaline KMNO4. The color of alkaline KMNO4 is violet. The color of alkaline KMNO4 is violet. So this violet color alkaline KMNO4, okay, is added. Same entire process, same only, but the color variation is observed. When you are adding, after adding alkaline KMNO4 drop by drop to ethanol, which is kept in a water bath, okay, now it is going to convert into, that is CH3CHO, and again it is going to convert, further reaction takes place, that is, here is ethanal or what is that? Acetaldehyde. Acetaldehyde. I hope you understood. Next, now again this CH3CHO which is called ethanol or acetaldehyde, is going to convert in presence of alkaline KMNO4. Okay, so that is CH3 COOH, which is nothing but final product acetic acid is obtained after complete oxidation reaction. Okay, so CH3 CH2OH or CH5OH, there is nothing but ethanol. Ethanol is converted into ethanol. Again, this ethanol is converted into acetic acid. Okay, I hope you all understood this. Okay, now with this the end of oxidation reactions of what? That is ethanol. I hope you all understood this. If you like my explanation, please like, share and subscribe.